So there's several things we should notice in order to use burst buffer. First thing is to change your existing batch script to add several lines to specify the resources. For example, most importantly, you need to tell the data warp how much space you will need by specifying the capacity. And the access mode, by default recommended is the striped, and the type is a scratch. And stage in is important because that allows you to stage in to basically copy some data on Lustre scratch to the burst buffer so that you can use your data there. Suppose your application will need some input, you will need this stage in command. And stage out, so after running your application, you produce some output, then you will need to specify the stage out, and then burst buffer will automatically copy your data from burst buffer node to the location you specified, which should be your scratch on Lustre. So you may be a little bit confusing about the scratch that I constantly mentioned. So the scratch I'm talking about is a location on Lustre, on Cori Lustre file system. You can use this CD $ scratch, capital scratch. You can CD into that, and then PWD to see your to see this absolute path. So this is the basic steps to start to use burst buffer. And for trying those example scripts and example code, you can go into your Scratch directory and then clone this code. And first example is very simple, just to try this burst buffer and to see how does it look like. So, for example, you can put your reservation name here, which is reservation equals add PSC 18 minus Haswell, or you can use the KL resources. But if you use Haswell, then you should specify your type here, node type here. And for running this script, just use sbatch and scratch.sh. After submitting the job, you can query the status of your job using sq minus u and then your username. So you could see something like that. So it reports the status of your job, whether it's configuring all the resources for you or is still waiting in the queue. So here you may ask why with the reservation we still need to wait in the queue, because the reservation is only for the computer nodes. So you don't have to wait for that kind of resources. But for burst buffer resources, it's still shared. And then for creating a data warp space will take some time. So that's why we still need to wait a little bit. Yes, question.
So you're saying, you're telling me that you'll be allocated the compute nodes, but then you need to wait for the burst buffer nodes as well.
Yes.
Are you charged for the compute nodes when you're waiting for them? Waiting for the burst buffer nodes?
The job is not on the computer node yet. So only when all the resources you requested is ready, then your job can start to run. Yeah, and there's some useful command like s-control show burst to check what the burst buffer is doing now. Yes?
So which configuration should we use if we're on Edison? You only show for the Haswell and KML in the slides.
Oh, I haven't tried that. Let me see.
It's only Cori.
Only Cori, right? By running this s-control show burst, you can see all the allocated reservation. and the size for each reservation. You can see like the granularity is 20 gigabytes. So that's why if you request 100 gigabytes, it will give you 5 nodes, 5 burst buffer nodes. And stage in. So like I said, if your code needs some input, you can try this stage in. The change you will need to add on the previous script is that is here, pound sign DW stage in, and specify where is your input, and the type, meaning that you want to stage in a file or directory. You can stage in both types. And stage out, similarly, you can specify the destination of your output. The destination should be only on the scratch. That's the only supported resources now. And you could also create persistent reservation, but I wouldn't recommend trying this during this session because I think the waiting time is much longer. And after creating a persistent reservation, in your script you can just specify the name of the reservation, and most importantly, don't forget to delete the reservation, because otherwise it will just stay there and all the resources are idle. I think it's interesting to just try the burst buffer interactively. So by using the interactive queue, basically you can have less turnaround time, and you can debug your code. That's what we do with the interactive queue mostly. And then for using the interactive queue, you can specify the configuration for burst buffer. Basically, you can just put this configuration in a file, and then when you request the interactive queue, take this as the example, as alloc, I want the interactive queue, and I want Haswell node, and then I want 5 minutes, 1 node for that, and then give it the burst buffer configuration file. So once that job is approved, you got one Haswell node, and you got access to what you requested for burst buffer. And then you can directly run the job on the node that returned to you. So just, for example, run this IOR. You can type on your terminal srun, 8 processes, and write and read some data, and specify the location. So you have this environment variable, which can tell you the absolute path on the burst buffer. You could also compare the I/O performance on burst buffer and the Lustre. So I prepared these simple scripts. So you can create a directory on your Lustre file system, and then, like I mentioned before, you can set the stripe count, stripe size. For example, here I want a 5 OST, why 5 OST? Because I want to have a fair comparison with what I'm doing on burst buffer if I request 100 gigabytes. So I got 5 burst buffer node. So I want to have 5 OST on Lustre. So relatively fair comparison, but it is not exactly fair. And then I want to specify the stripe size, 20 megabytes. And this is the directory name. This is the directory I want to change the striping configuration. And you don't have to do this because on Cori, Darshan is loaded by default, unless you unloaded it by default. So then you can run the job there and to exercise the performance on this Lustre file system. And you could also grab all the Darshan logs for the 2 jobs you just submitted, one on burst buffer, one on Lustre. The jobs are located at global C scratch SD/Darshan logs, and then the date of today should be changed to 3 here, and you can there will be a lot of logs, so just find your own log. Your log, the log's file name starts with your username. Another useful command is a dwstat. You can check. You can / this script to check the burst buffer resources that you requested, and the sample code running h5py on burst buffer. So parallel write.py, you can just run this script with those commands. You can explore different I/O methods, collective I/O or independent I/O. You can specify whether write to burst buffer or just a Lustre file system. You could also take a look at the IOR script. Yeah, those are the 2 sample codes you can play with. I also recommend to try with your existing code, so that will be more useful, I think. But if your existing code is too complex, and during this 1-hour session you want to learn something, maybe just try the sample code. That will be convenient. With that, I think I will just go around, and feel free to raise your hand if you have any questions. And the code is on the GitHub.